Hello everyone, this is Joy. I am very excited of today's topic, which is about independent samples t-test. Now I'm going to discuss its purpose, uses, limitations, and after that we will run the analysis by using SPSS. Now the purpose of this test is to test whether or not the population represented by the two samples have different mean. Independent samples t-test is a parametric test. This means that the test assumes that the population data has a normal distribution. Now, the common uses of this test is comparing differences between separate groups. Now, we can measure the significant difference between the means of two groups, categories and variables. We can have two interventions or two change scores. Just please note that this independent samples t-test can only compare the means for two and only two groups. Now, let's study the limitations of this test. Number one, we have types of variables. Number two, sample size. Number three, assumptions. Now, for the types of variables, independent samples t-tests assume that grouping variable or categorical variable should be measured on nominal scale. Next is the test variable should be measured on interval or ratio scale. Now, the types of variables, there are data requirements. The first one is dependent variable should be continuous and independent variable is categorical. Now, as you can see in the data provided here, the level of measurement here, there's scale, there's nominal, and then scale. And then, for the sample size, the t-test is the most powerful parametric test for calculating the significance of a small sample mean. So, sample mean, small sample, is generally regarded as one of size n is less than 30. However, can still be applied to larger samples. Number three is the assumptions. We have here three assumptions. The first is the two groups are independent to one another. Number two, the dependent variable is normally distributed. And number three, the two groups has approximately equal variance on the dependent variable. To create research question, we have here independent variables and dependent variables. So I come up with the independent variables, which is sex. The two groups is males and females, and the dependent variables, the grid scores. Now the research question will be, is there a significant difference between males and females in terms of their grid scores? Now, we will use SPSS later after the end of this presentation, but before that we will discuss and follow the steps of hypothesis testing. First will be to state the null and alternative hypothesis. Number two, set alpha and level. Number three, run analysis in SPSS. Number four, compare test statistics. And number five, make decisions and conclusions. Now for step one, state the null and alternative hypothesis. Now, for null hypothesis, males and females have no significant difference in terms of their grid scores. And for our alternative hypothesis, we have there is a significant difference between males and females in terms of their grid scores. For step 2, we have to set an alpha level, which is 0.05. So, if you will ask me what is significant level alpha, the significant level is also denoted as A, or is the probability of rejecting the null hypothesis when it is true. For example, the significant levels is 0.05. That means that 5% risk of concluding that difference exists when there is no actual difference. Now we have here the run analysis. So to run the independent samples t-test, there are screenshots below that will walk you through. Number 1, this is number 2, number 3, number 4. Now I'll show you how to run an independent samples t-test in SPSS. Here are the data and then the variables. We have here the student code, pretest, post-test, sex, group, highest educational background of father, and then the grade score. And what I want to find out is there a significant difference between males and females with their grade score? Now I just need to run the t-test. First, just click Analyze, hover over Compare Means, select Independent Samples t-test, and then as you can see on the screen, the test variable is the variable we are testing. It's our dependent variable, and that would be the grade score. Click this arrow, and then here is the grouping variable. This is the independent variable, and that would be the sex, male and female. So just click this arrow to move that to the grouping variables. Now we have to click Define Groups, and the values that are used from the worksheet were 1 for male and 2 for females, and so we're gonna put 1 and 2, and then click Continue, and then click OK. So here are the results of our t-test. Now the first thing we want to look at on the output is the Levine's test for equality of variances. So if the value is above 0.05, then you can use the first row, which is equal variances assumed. Then you'll want to use the bottom row if the equal variances not assumed. So in this figure, we can see that 0.132 is larger than or higher than 0.05, so we're going to use the first column. So the next thing we want to look at will be the p-value. Okay, the p-value is this significance two-tailed here. So our alpha level for the test is 0.05. So let's scroll over this column, and we've got here the significance two-tailed 0.522. This is our p-value, which is higher than the 0.05. That means that there is no significant difference between males and females in terms of their grade score. And that's how we run an independent sample t-test in SPSS. Read first or interpret first the output table. So as you can see, the p-value is here, the significance two-tailed, the level of significance, and here is the variances. And for p-value less than or equal to alpha, we reject the null hypothesis and say the data are statistically significant at the level alpha. So if p-value is larger or greater than or equal to alpha, we do not reject the null hypothesis. So our p-value is here, and the level of significance is alpha equals 0.05. Now for step 4, we now compare test statistics. Now 0.522 is from here, from significance two-tailed, is greater than 0.05. Now for that, p is greater than 0.05 is the probability that the null hypothesis is true. P value greater than 0.05 means that no effect was observed. So for this, you should not note that we cannot accept the null hypothesis. We can only reject the null or fail to reject it. Now for step 5, we will now make decisions and conclusions. Since the p-value is greater than 0.522 to our chosen significance level alpha, which is 0.05, we cannot reject the null hypothesis and conclude that the males and females have no significant difference in terms of their grade scores. So based on the results, we can state the following: there was no significant difference between males and females in terms of their grade scores. So that's all from my report. Have a great day, everyone. Bye bye.